Hello AB Calculus students. We are working on 2018 question number 3. The topic is, this is an FTC question, Fundamental Theorem of Calculus. And here's the graph of G. Notice G, straight line, that's flat, straight line, straight line, straight line, straight line, parabola. And this parabola starting at 3 to 6 is given by this equation, and we'll need that in a bit. Now, one more insanely important detail, and I know in 2018 some of my students didn't pass the exam because they missed out on one detail of the question. They said the graph of the continuous function g, then it says the derivative of the function f. It was just in writing. They're saying this is the graph of g, which is the derivative of the function of f. Well, the derivative of function f is f prime x. So while they're telling you this is g, this graph is also called f prime, the derivative of f. Insanely important, and such a small detail. Alright, so let's go ahead and start with part A. So part A, they want to know what is f of negative 5, and to help you out, they told you f of 1. They said f of 1 is 3. Now, quick reminder, what does the area underneath f prime x give us? From negative 5 to 1. Remember, the area underneath f prime x gives the net change in its antiderivative, f of x. Meaning, if I were to work this out, I would say the antiderivative of f prime x is f of x, and then I would plug in the top and the bottom and subtract f of 1 minus f of negative 5. And notice in this problem, they give us f of 1 is 3. This is what we're trying to find, and we can find the area underneath f prime x because this is the graph of f prime x, and all the pieces are there. So just to remind you, this is how the formula looks, but we always rearrange the formula. We rearrange it to, if we want to find the final, it's initial plus net change, or if we want to find the initial, it's final minus net change. And we get those equations by rearranging this. So I look at these two and see which one comes first. This comes before this. So we actually are looking for the initial, and we are given the final. So if you have the final and you want to work backwards and find the initial, you have to subtract the net change. So we need the area underneath f prime x from negative 5 to 1. Okay. So again, to find my final, my initial, I need my final. They gave me this as 3 minus, and now I'm going to find the area underneath f prime x from negative 5 to 1. Okay, so when I go to find that area, I'm going to start by finding the area right here. And that's a rectangle. And this rectangle is 1, 2, 3 by 1, 2, 3. So that rectangle is 3 times 3. You could just call it 9, but very important because it's below the curve, you put a negative in front of that area. So it's a negative 9. We need to know if the area is above or below. We're going to put a negative or positive in front of the area. And now we have a triangle. 1/2 base times height. The base is 1, the height is 3. So the area of the triangle, again, is just 1/2 base times height. Base is 1, height is 3. But again, it's below the curve. So since it's below the curve, we're going to give that area a negative area. We're still got to go all the way to 1. Well, there's no area here, but now we have this area here. And again, 1/2 base times height. The base is 1, and the height is 2. Do not waste your time simplifying this. This is going to be on your AP exam. You're not going to simplify it. Leave it. You got all the points. And again, all that was for part A. So part A is now done. Part A was an important question with 2 points. And now let's move on. Alright, so now let's go look at part B. Part B, they say find the area underneath g of x from 1 to 6. And the first thing I'm going to notice is when I find the area, so here all that stuff is gone, if I want to find the area starting at 1, all the way to 6. If I want to find all of this area, first thing I notice is it's the area first underneath this, and then it's the area underneath this parabola. And while I know the area of that, that's a rectangle or square, I can find the area of that. There's no way of finding the area underneath the parabola unless you use calculus. So here I'd have to break this up. I'm going to break it up and do the area from 1 to 3, which of course is just 2 times 2, which is 4. You can simplify it if you want to. And then I need the area from 3 to 6. And from 3 to 6, I'm taking the area underneath this. Alright, so how am I going to find the area underneath this piece? Well, I'm going to take the antiderivative, plug in the top and the bottom, and subtract. And let's just quickly look at this. So how am I going to take the area underneath this? So the first thing I'm going to do is I'm going to do u substitution. I want that to be a u. And I say, if my u is x minus 4, my du should be a 1 dx. Do I have a 1? No, I have a 2. But I already have a 1 dx. That is a 1 dx. So I'm going to change this to a u. So that is now my u. I already have a 1 dx, which changes to a du. Now you might be like, and I forgot the squared, so it's u squared. You might think, well, Mr. Pygate, don't I need to put the 2 to the outside? Well, if you want to, you can put the 2 to the outside. It won't change anything. Either way, if I leave the 2 here, or I say, the 2 is not what I want, I put it outside. Either way, the 2 is here, I add 1 to the exponent, and then I divide. Or if I have the 2 out here, I add 1 to the exponent, and I multiply by the reciprocal. But you can see either way, it's 2/3, and this is 2/3. So anyways, it's going to be 2/3 u to the third, and u gets replaced with this. So I have 2/3 u to the third, where the u is x minus 4, and remember I still have to plug in the top and bottom and subtract. So this piece doesn't get the whole top and bottom. It's already, this is something different. So this is 4 plus, and now I'm going to first plug in the 6. So I plug in the top, and now I'm going to plug in the bottom and subtract. So minus, oops, forgot to actually plug it in. Let me put that 3 there. So put the 3 there. Alright, so I plugged the 6 in there, 6 minus 4. Plug the 3, 3 minus 4. And I'm not going to bother simplifying this. I'm done. So the area from 1 to 6, we did the area from 1 to 3, which was just the square, and then the area underneath the parabola. Again, we took the antiderivative, plugged in the top and the bottom, and subtracted. And I'm leaving it there. There's no reason to simplify it. Done. So that's the end of part B, and we'll go to part C now. Whoa! Let me not erase too much. I'm going to erase some of this mess I've made on my picture. Okay. Alright. So now let's go look at part C. For the interval -5 to 6, on what intervals is the graph of f both increasing and concave up? So let's quickly discuss this. When is a graph increasing? When is f increasing? F is increasing when f prime x, its derivative, is positive. Or in other words, for positive, when f prime x is greater than 0. And they also want it to be concave up. So when is f of x concave up? Well, that's when the second derivative is positive. Or in other words, the second derivative is greater than 0. Okay. So we need to know, when is f prime x positive, and then when is f double prime x positive? Now, you don't have to make sign charts. You can literally look at this problem and think with what you know and get the answer. I'm going to show the sign chart. It's a little overkill, but the sign chart could help me with a lot of questions. So let me just make a sign chart of f prime x. It's going to be a little crazy, but f prime x goes from -5 all the way to 6. And remember what graph we're looking at. This is the graph of f prime x. So notice f prime x has all negative values here, positive values, and positive values. So when does it hit 0? Well, it's actually at 0. This is weird. But from -1 to 0. So from -1 to 0, this whole time, it's not positive or negative. It's actually 0. But over here we have negative values. Then it's 0. It stayed 0. And then from here all the way to 3, it's positive and then positive again. So when they want to know when is f prime x increasing, f prime x is increasing from 0 to 6. All right. Now we need to know concave up. When is the second derivative going to be positive? So let's make a sign chart of the second derivative. Again, we don't have to do this. We could just look at it, but let's do this. What features of this graph, what features of f prime x tell me about its derivative, f double prime x? So we want to go from f prime x to f double prime x. That's one derivative down the road. To learn about something's derivative, you look at slope. So let's look at slope. My slope is 0. So from -5 all the way to -2, my slope is 0. Okay? And then from here to here, I have a positive slope. So from -2 to -1, I have a positive slope. And then from -1 to 0, my slope is 0. So weird having a slope of 0, a slope of 0. Okay? And then a positive slope until I get to 1. And then again, a slope of 0 until I get to 3. And then a negative slope until I get to 4. And then a positive slope until I get to 6. So I looked at the slopes. 0, positive, 0, positive, 0, negative, positive. And there it goes. And again, concave up means the second derivative is positive. So the second derivative is positive here, and here, and here. So remember in this graph, we are looking for where both of these are positive. So they are both positive here. From 0 to 1, 0 to 1, they're both positive. And then here, from 4 to 6, they're both positive. So we would say f of x is increasing and concave up. And then we could say either from 0 to 1 and 4 to 6, like this, or 0 to 1 and 4 to 6, like this, doesn't matter. And then they ask you probably to justify. Give a reason for your answer. Yep, so because f prime x is positive and f double prime x is positive. And again, if you're going to say they're both positive, you show your sign charts. And that's it. That's the end of part C. Ah, I didn't label it. It's part C. Oh, that was part C. Okay. So all this is part C, and let's I'm going to erase this. But notice I'm leaving this for part D. Alright, so part D is kind of a sneaky question. Only time I've ever seen this before. They want to know points of inflection for f. A point of inflection is a point. It has to be a point where the concavity changes. So you have to go from concave up to concave down, or concave down to concave up, which means the second derivative goes from positive to negative or negative to positive. So look at the second derivative. Any one of these maybe could have been points of inflection, but no. This one, 0 to positive. So 0 doesn't mean concave up or concave down. There was no concavity and then concave up. And it was, and then from here, concave up, no concavity. No concavity, concave up. Concave up, no concavity. No concavity, concave up. This is the only place where concavity changes. F double prime x changes from negative to positive at this point. Everywhere else it changes from 0 to a plus, or a plus to a 0, or 0 to a minus, or minus to 0. So, point of inflection for f of x at x equals 4, and then justify because f double prime x changes signs. Now, this reason for f double prime x changing signs or going from negative to positive only works as a justification if you have labeled a sign chart. If you make a sign chart and you don't label it, they will not give you the points for your justification. Label your sign charts. If you don't want to label your sign charts, then you could say instead that 4 is a point of inflection because it's where f prime x went from decreasing to increasing. That's the only other way to get around it if you don't want to make a sign chart. All right, that's the end of that question. Thank you so much. Thanks for joining. Bye.